everyone. All right, let's solve one of these tricky substitution problems together. All right, the story problem says Miss Gunther and Miss Thompson go to a show together. Miss Gunther spent $15 and got 3 red vines and 7 Mike and Ikes. Miss Thompson spent $10 and got 2 red vines and 6 Mike and Ikes. How much do red vines cost and how much do Mike and Ikes cost? Solve by substitution. First thing I want to do is probably write out some equations here. I'm going to use blue for Miss Gunther's equation. Let's see. It looks like Miss Gunther spent a total of $15. So I'm going to say 15, and this is for Gunther. 15 equals, she got 3 red vines. Okay, so 3, I'm going to put R for red vines, and 7 Mike and Ikes. Alrighty, so I'm going to say plus 7, and I'm going to say M for Mike and Ikes. Alrighty, let's make a little Miss Thompson equation as well. Miss Thompson spent $10. She got 2 red vines and 6 Mike and Ikes. Alrighty, not too bad, not too bad. Alrighty, now we gotta choose, we gotta solve by substitution. Meaning I'm gonna need to get one of these guys one of these letters by themselves. I either need to get R by itself or I need to get M by itself. Let's see, I'll probably try to get this R by itself because all this is even, so I know it'll go in evenly. Alrighty, oops, that's not what I meant to do. Here we go. So now I'm looking at this, I'm like, okay, what's happening to this R? Looks like it's got a 2 by it, so I'm timesing by 2. And it's also being added to 6M. When I say what's happening to R, what I mean is I want to get R all by itself. So what's making it so the R is not by itself right now? Looks like a times by 2. It's making it so it's not by itself. And then a plus 6M is making it so it's not by itself. Alrighty, well, if we're doing reverse PEMDAS, so let me write that out. So if I'm doing reverse PEMDAS, so I'm going to go the other way, what comes first? The addition or the multiplication? If I'm doing reverse PEMDAS, it has to be the addition, so I'm going to get rid of that first, this plus 6M. Let's see, what's the opposite of positive 6M? Minusing 6M. So I'm going to minus 6M from both sides. Oops, minus 6M. And when I say both sides, I mean both sides of the equal sign. 6 minus 6 is 0, so that cancels. 10 minus 6M. Well, 10 and 6M are not like terms because 6M has a letter and 10 does not. Because they're not like terms, I cannot combine them, so I'm just going to write them side by side. I'm going to write 10 minus 6M, and that's as simple as it gets. That's the answer for that side, equals 2R. Alrighty, if I'm doing my reverse PEMDAS, after addition will come multiplication. How do I get R by itself? Well, I get rid of this 2. The 2 and the R are attached by timesing. Remember, anytime I've got 2 things and they're smushed together, I'm timesing. So how do I undo timesing? I'm going to divide by 2. Divide by 2. This cancels, and I'm left with just R. And I'm actually going to rewrite this to make it a little bit more clear. I'm going to rewrite this to say 10 divided by 2 minus 6M divided by 2. And then this makes it a little bit easier because I know what 10 divided by 2 is. I know that's going to be 5. Minus, and then 6 divided by 2, well, I know that's going to be 3. M equals R. Now, anywhere that I see an R, I can plug in this equation instead. Please make note, this and this equation, these are both Thompson equations. We derived or we created this equation from the Thompson equation. If I try, I say anywhere I see an R, I can put this equation in instead. And that's kind of true, but it's not as helpful if you put it into the Thompson equation. It's not as helpful if I take the Thompson equation and put it back into itself. So it's a good practice to alternate. So this is the Thompson equation. So I'm going to put the Thompson equation into the Gunther equation. So I'm going to write this out. Here's the Gunther equation. It's 15 equals 3R plus 7M. What goes in here is R. I know R is 5 minus 3M. So that's what I'm going to put in here. 5 minus 3M. Again, anywhere I see R, since R is or equals 5 minus 3M, I know anywhere I see an R, I could put in a 5 minus 3M. Alrighty, let's solve this baby out. I know since I have parentheses, the first thing I want to do to get rid of parentheses is distributive property. We've been calling it the Santa hat property. Both are fine. Okay, so 3 times 5 I know is 15. Minus 3 times negative 3 is 9M. Plus 7M, and I'm just going to drop down everything else. Okay, next up, I probably want to combine like terms. These two M's are on the same side. Negative 9M's plus 7 more M's. Well, that's going to give me negative 2M's. Negative 2M's. Drop down everything else that we've used so far. Okay, now, I want to get this M by itself. I'm going to do reverse PEMDAS. What comes first, this times by 2 or the positive 15 I have here? Well, in reverse PEMDAS, the addition, the positive 15 comes first. What's the opposite of positive 15? Minusing 15. Minus 15. That cancels. And what's 15 minus 15? 0. A lot of people get stressed out when they get a 0, but it's just a number, so don't stress. Okay, next up in reverse PEMDAS, after we've taken care of our addition, we know our next thing's multiplication. We're going to take care of this multiplication happening here. The opposite of timesing by 2 is dividing. Oh, and I should have said negative 2, so I'll divide each side by negative 2. Divide by negative 2. That cancels, and I get 0 equals M. Meaning the price for Mike and Ike's, so Mike and Ike's, are $0. They're just giving them away as like a free thing that they're just handing out. So that's nice. Alrighty, so since I know that Mike and Ike's are $0, how can I use the fact that M equals 0 or 0 equals M to figure out how much the red vines cost? Right here, we're going to apply the same principle that we applied over here. Anywhere I see an M, since M equals 0, then anywhere I see an M, I could replace it with a 0. They mean the same thing. They're the same thing. Because of this equal sign, they mean the same thing. Alrighty, so anywhere I see an M, I can plug in this 0. So that includes right here. In the Gunther equation, it includes right here. In the Thompson equation, that's all fine and good. You can plug it in right there, and it ends up not being too bad. However, I'm solving for red vines. This equation down here already has R solved. So I'm just going to probably go ahead and take this M and plug in a 0 right there. I'll use a different color. Let's use red. Alrighty. So 5 minus 3M, I know M and 0 are the same. M equals 0 equals R. Now let's solve this out. What's negative 3 times 0? Well, it's 0. So I'll have 5 minus 0. Wait a minute. I don't even think I need to write the 0, but I guess we can. And then what's 5 minus 0? 5. Meaning that red vines cost $5. So kind of a steep price increase there. I mean, whatever. Red vines are a lot more expensive than Mike and Ike's. I don't know what's going on there. But the way I would write my answer is I would write 0, 5 to say that Mike and Ike's are worth $0 and red vines cost $5. If there was any part in this that you got confused, rewind it, watch it again, call me over. I'd be happy to help you. Good luck. I believe in you.